We start from scratch, opening Simulink so that you get a good feeling on how to develop such a unit from the very beginning. The model is called Untitled, and we will save it with a different name. We know that the model is defining the thermostat, TMS, and we are not developing the thermostat right away. It's going to be the test harness in which we are developing it. So I call it a harness for the thermostat. We use the MDL format for now. So this is our empty model. And now I will demonstrate you how to develop, but also how to do it in an easy way with our tools, EverCheck and EverTest. For those of you who do not have these tools, you might get a trial. For those of you who use other tools, just imagine how you can do it with other tools and just skip it for now. I hope it will not bother you too much. I need some kind of a test harness, and I go to EverTest and create EverTest harness, which will be a default test harness. So this is my test object, and the signal naming is not quite what I wanted. And also this Excel file is something that I do not really need. So what I need, I want to preserve the test object. I will rename it to TMS. So this is what we are building. And now I will go inside of that test object and see I have some reminder on how to develop it. So this is the title, call it TMS. And in this description, we should describe what we are actually developing. I can see it well over here. So this is the unit specification, and here is some management summary. So I will just copy this summary and put it over here. So it describes what this kind of unit is doing. And this will help you every time when you go into some kind of a unit, you will read right away what it is good for. So the next is the interface. So let's define the interfaces. They're fully defined in the specification already. It simplifies our job. So we have two inputs. One is diff. I just rename it to diff. And it says that it is integer 8. To rename this, I just double click on the import and go to the signal attributes. And here I can define my min and max values, 127, the data type, which is integer 8, the unit, which is Celsius, degrees, port dimension is 1, variable size no, signal type real, yes, I'm all set. Very happy with this. Then I need another input, which is the ready flag. Can double click here, introduce a new import, call it ready flag. Now I see the color is not quite working, but we will see later how to fix it. All right, double click on this, signal attributes, inherit is the unit, not available is good. Minimum maximum values are 0 and 1. And the data type is Boolean. Specify the port dimensions to 1. You can imagine that if you use the standard blocks that you will forget to set some parameters, but the static checkers will help you with this. So we have two inputs. Now we need an output. For the output, I have one. I will just rename it. It says double now. Do not quite agree. This is Boolean in our case. And so we set it to 0 and 1 as minimum maximum and set Boolean unit is 1 or inherited is okay. Port dimension is 1, no, fine. I can also produce a signal here. So this is the switch on. So we now have inputs and outputs. For the parameter off and on, we have two booleans. So now I will rename that off. Later on, I will demonstrate to you that we will use the Simulink parameter objects for this, and we will define for the parameters, we will define all of the settings in that Simulink parameter object. So I will not do much here, just close it like this. This is the off. Then same thing for the on. It says they do not exist yet. That's okay with me for now. Then we have the on threshold, and here is the off threshold. So those are our parameters. As you see, we want to use variables, and that's why those parameters are named. Those are all of the interfaces now. The model is not updatable because these parameters are missing. Copy these parameters over here and now define those very quickly. Off is 0, on is 1, threshold is -20, I believe, and on threshold is 20. I need this in this way just to make sure that this model is updatable. Now it is, and it gives me the chance to develop a test harness with these interfaces now. The interfaces look good. So I go to EverTest again and create an EverTest harness, which will pull all of the parameters and will move those to the interface table. And the interesting thing is that for the fully defined parameters, we now have full definition here also. So we see pretty much the same parameter list here. There are some problems. So with the type is okay, with the naming is okay. With the data types, we have a trouble. These data types for imports and outputs are fine. For the off, it should be Boolean. I just copy it over here, like for the on, but the min-max values are set correctly. That's good. And for the off threshold should be integer 8, right? So I copy it here. And the min shall be -20 to 0, -20 to 0. And on threshold 0 to 20. So those are not constants, those are parameters. And then the unit shall be Celsius for this and 1 for the rest. Now you see some troubles with these colors. This is not a problem. Here in EverTest, you can use the cleanup button. Look at the interface again. Now the colors are fine. The interfaces are all defined. And if you go to this sample test case, you also will see that all the interfaces are in the same order that we want. So we have the parameters. We can redefine the parameters for each test case here. And also the first sample set is provided. And we actually might start our test-driven development. If you click on the debugger, you will see that now you are ready to do your test-driven development. Basically, you go here, you can pass values and start your implementation. Good. So let's do a little cleanup. So the next step for now would be to set this under version control. The next step of the cleanup would be to run the static checker. It is already needed because of missing features here. Some information is missing, like for example, min-max values, right? And the easiest way of doing this would be go to this level, right mouse click, go to EverCheck. What I do at this point, I actually run and fix all of the problems right away without looking much into what's going on. So we can run selected checks, but I also fix those right away. And so you will see that the settings will change a little bit. And as soon as the labels are grayed out here, it means that somewhere on the way, the other checks were executed and fixed also. These fixes help a lot in improving the quality of the models and also understanding of what's going on. you can see that if I run the checks, it will take a little time, but it will not show too many problems. So there is a problem with the verification unit. It says it shall be a library. TMS shall be a library. And yes, if I develop it as a unit, it shall be a library. So I will right mouse click here, go to the libraries and convert it to library. So now it is a library. Where is it stored? It is over here, TMS lib. So you see, it did create a library based on the requirements. TMS is the unit, and lib with the underscore shows that it is about the library. This is not regular model. So I've done this, run it, seems good. And now I have a problem somewhere over here. And it says that some blocks are used that are not recommended. And yes, we provided a couple of blocks here to demonstrate that they are connected. So that was a fix, but they are not allowed in regular systems. You can provide a rationale, but we will actually delete those. How do we work here? We just move one of the blocks. It says disable this link. Yes, disable. Disable means that now it is connected to the library, but it is not fixed and we can work in it. And later on, we can push the changes. So you can imagine if your library is now on the version control, it will not be changed. We are just changing something here. And later on, when we are done, let's say we do some very important changes, we also can push that changes to the library like this. The changes are pushed and we are now connected and logged with that library. But for development, we actually want to work in a disabled library. And now we are ready for implementation. Here is our requirement ID. I will just copy it over here as an annotation. This is the reminder what I want to implement. If diff, which is this signal, is bigger or equal to on threshold, which is this signal. So let me move it down. So this is the relational operator, bigger or equal. So this is this part. And ready is true. I will skip it for now. I can switch on. I use the switch block. And this is my trigger in Simulink. If it is true, then I need to set it on. I will set it on. Else if, and this is this else if, diff is smaller or equal to off threshold, I will copy with the right mouse click and define it here, smaller or equal. So now I compare diff and off threshold. Then it shall be switched off. So I need a switch, right mouse click over here. So now we have the switching part. Did not implement the ready part yet. So I take the ready part and it says the heating device is in ready state, should be switched on. The heating device in ready state should be switched off. And with ready off, it shall always be off. So I need a logical operator, the AND. And basically, if it is off, this AND will always provide off for that switch signal. Okay. So basically, no matter what kind of decision will be done here, it will always go to off if the ready flag is not provided. If the ready flag is provided, then this path will be well used. And this is the path that we want to use for that switch on last state. This is the last state of the switch on. and enough. If nothing is changing, then this state will be provided. For this, I need a unit delay, and I will just set it like this on that line. So this is switch on. If I double click on the signal will also appear here. And this is the switch on old. With the right mouse click, I can copy it to this part of a signal. Now, if you look at this model, and this is the spatial representation now, we see that if the difference is bigger or equal than on threshold and ready flag is true, this is this part, then it will go on. So basically, if it is called, then this path will be executed. Otherwise, else if diff is smaller or equal to off threshold, smaller or equal to off threshold, should go off. It means this is warm and it goes off. And we'll keep the old signal if those are not true. So basically, if this signal is true, then the on will be used. If it is not true, then this path will be used. Then we'll look. If this is true, then off will be used. And if this is not true, then this path will be used. And this is the old signal of the switch on. And we will only reuse both of these switches if the ready flag is set to on. So this is the idea. And this is the requirement that we implement. Now, the next step would be to run the fixes again. We'll see that the settings will change. Now the model is better readable. The requirement ID got another coloring, and we might start testing now. Let me check whether something is not quite done yet. There is a library problem. If I click on this, it will be loaded. Now if I run it, it's green, okay. And then there are some problems with the format of the requirement. Again, modify, run. Let me see. Now it's also bold. So I guess that now the Simulink checks are all done. All right. What is about state flow checks? Let's run those. Those are also done because we do not use state flow yet. We have a summary here. It says something is wrong. Yeah, the library is unsaved, as you see over here. And the Simulink library is disabled. So the test harness is unsaved and the Simulink library is disabled. Those are the problems. Otherwise, everything is okay. And let me see for the code generation. We will not use the target link for the code generation, whether everything is okay here. And it says there are troubles, that the interfaces are not quite well defined. So for the diff and ready and switch on, you need to redefine it. So I click on run, it will be provided. The unit delay is missing a good name. I will call it X. Is it a good name? No. Switch on old. Okay, what about now? All right. The code was not generated yet, and the description for the traceability is not provided yet, but now it is also done. We will generate the code later, but for now I think it is sufficient. So I close the static checker. As you see, we did not spend too much time on the static checker. And now I will also push the library, and we now can start testing.